All right, guys. We're going to do some complex circuits where we're going to mix series and parallel and a lot of branches. So one of the problems we're going to do is the one you see on the board here. The numbers that you see here next to the resistors, that's just the ohms, the value of the resistors. So the best way to do this, and you could do it any way you want, but the best way to do this is you take this circuit, and you simplify it maybe multiple times, and then you work backwards. So I'm going to try it my way. If you have another way, just go for it, okay? So this circuit is going to be equivalent to a 3 ohm here. Now, this 7 and this 10 are in series. The 15 and 4 are in series, but the 9 and the 9 down here are in parallel. So I'm going to replace this 7 and 10 with the 17. I'm going to leave the 5 alone. And I'm going to replace the other ones with the 19. Now I'm going to replace this 9 and 9 in parallel with a 4.5. Okay? And then my next step is this is 45 volts, is to change this one more time. So I'm trying to make a series circuit out of this. So I have a 3 here. Now all these 3 in parallel should give me 17 negative 1 plus 5 negative 1 plus 19 negative 1, and we have to flip that, negative 1 that. So I get 3.21. And this is all in ohms, of course. This is 4.5 ohms. This is 45 volts. So we're going to start working backwards. So the first thing I'm going to do is that I'm going to find the current going through the whole circuit. So in order to do that, we do 45 divided by 3 plus 3.21 plus 4.5. So I get total current of 4.20 amps. Now we have 4.20 amps going through here, 4.20 amps going here, and 4.20 amps going here. So the next thing I do my voltage drops. So I do 4.20 times 4.5, and this is 18.91 volts. I do 3.21 times 4.20. This is 13.48, and I do 4.20 times 3, and this is 12.6 volts. Okay. Now we're going to go to the previous one. It seems long, but it's going to happen quick. Now, the 3.21 is the equivalent of all these 3 guys in parallel. Now, we know that in a parallel circuit or a parallel branch, the voltage is the same. So each one of these guys will get 13.48. Okay. Now we can find the current going through each one of these branches. So let me just write down. This is 18.91 volts, and this is 12.60 volts. All right, so now we can find the current going through here. So we do 13.48 divided by 17. We're doing V equals IR. So this is going to be 0.79 amps. We do 13.48 divided by 5. You can do this with proportions if you want. It's up to you. 2.7 amps. And we do 13.48 divided by 19. And we should get 0.71 amps. Okay. Now we can find the current going through here. 12.6 divided by 3. Well, actually, we already have that. It's 4.2 amps. And current going through here, we already have that. It's 4.20 amps also. It's the same. So we're pretty much done with this one. Now these two share the same voltage, and that voltage is 18.91 volts. 18.91 volts. Now to find the current, you do 18.91 divided by 9. Or, since they both have the same amount of resistance, they're going to split this 4.20 evenly. So each one of them will get 2.1 amps. So we're done with this one here. Now we go to this guy here. The 7 and the 10 are in series, which means they have the same current. So you have 0.79 amps going through here, 0.79 amps going through here. So to find the voltage drop, just multiply these two numbers. I think you see what I'm going with this. So, and then you can finish the rest. The same for the 5, you're pretty much done. You have all the information about the 5. For the 15 and the 4, since they are in series, they have one current, so which is 0.71, and you can find the voltage drop across each one of those by doing 0.71 times 15 and then 0.71 times 4. Or once you find this number, you subtract it from 13.48, okay, because that's the voltage between these 2 points here across the whole 19. The next problem that I'm going to try has to do with two batteries. It's even more complex than this. So it has to do with two batteries. And this one is on page 566 of your packet, of your textbook, I'm sorry. Okay. So it looks like this. So you have some internal resistance here, you have a resistor here, then you have another battery, you have another resistor for this battery, internal resistor for this battery, you have a resistor here, okay. Okay. Okay, this is 80 volts, this is 1 ohm. 20, 45 volts, 1 ohm, 40 ohms, and 30 ohms. Yep. Okay. Now they call in this current here I2, and you can call it whatever you want. They call in the current going through here I1, and calling this current here I3. So basically, think of I3 as the current coming from here. It comes to this junction here. It splits. So that's the junction rule. So I can say that I1 plus I2 is I3. Okay. If you look in your packet, there is some rules that we have to follow. Okay, and they're also on page 567. So, and I'm actually going to just show you these rules by doing the problem. So we're going to look at some loops here. I can create 3 loops here. I can create one inside the top portion. I can create one inside the bottom portion. Or I can create one covering both portions, like meaning on the outside. So the way I did this is I'm going to make my loop here. I made my loop to look like this. Okay, so I'm going to do a bunch of arrows so it's easier. Okay, so that's my loop. On the top, I made my loop this way and this way. Okay? Yeah. Now you can do the loop any way you want. And if you ever end up with a negative value for current, just make it positive and move on, right? So you have to read those rules that are in there. So here is how the rule works. Okay. If the direction of the loop is going from minus to plus inside the battery, that's a positive value for the voltage. Okay. If it's going the other way from plus to minus, then it's a negative. Okay? Yeah, that's what we're going to do. And yeah, and if the current, the direction of the current is the same as the direction of the loop, okay, then your voltage drop across that resistor is negative. All right, so let's try this here. So I'm going to look at the bottom loop here. I'm going to call it loop A, and I'm going to look at it, call that loop B. So in loop A, if I follow this loop here, this 80 is positive, okay, because the direction of the loop is going from the minus to the plus, so that's a positive 80, okay. This is just another way of saying conservation of energy. Now this current I2 is going in this direction through this resistor, but it's the same current going through the 20, so I think I can combine these two and make it a 21 ohm. Now the current is in the same direction as the arrow on that loop, so that's going to be minus, okay, 21 times this current here, I2. Okay, now we're here. So the loop here is going, if you follow it, it's going to be going from negative to positive, so that's a positive 45. Okay, and then if we continue in this direction here, we're looking at the bottom loop still. The current is going in that direction, that's I3, and the loop is going in the same direction, so that's minus, and I'm going to combine these two as a 41, but there's a different current there, I3 equals 0. That's conservation of energy. So now we're going to do loop B. Should we skip loop B? Yeah, we could do it. Why not? Okay. So in here it's going to be negative 45, okay, based on this. So it's going from plus to minus. Now I'm going to get up here. So the current is going in this direction, and the loop is, oh, this is in the wrong direction. That's what it was. I'm actually going to do it exactly the way I did it in my notes. So I think I did it this way. Yeah, that's what I did. Okay. So let me change this negative 45 to 45, because now I'm going from the minus to the plus. This is 41. Okay. So that's 41, and the direction of the current is in that direction. The loop is in that direction, so that's minus 41 I3. Then I'm here, so the current is in this direction, and the loop is going in that direction, so I'm going to make that minus 30 I1 equals 0. Then I can also look at loop C. I don't have to do that, but if you do three of them, if you do two of them plus this equation, you have three unknowns, three equations, you can solve that. Okay, and here I think I did it with yeah, I did it with when I did it, I skipped this part here. I didn't use loop A, but you can. So if we do look at the outside loop here, which I'm going to call C, this whole thing out here, and I'm going to go in this direction. I think that's what I did, this direction. So let's see what it's going to look like. Okay. So this is going to be a positive 80. Okay. Now I'm going to follow this current here. Okay. So the current here is in the same direction as the loop, so that's going to be minus 21 I2. Okay. Now I'm going to go all the way to the outside. And then it looks like it's plus, because now the loop is going in that direction to the left, and the current is going to the right. So plus 30 I1, I think that's it, equals 0. So let me just make sure I have the same stuff here. Okay. I think I forgot. This is 41, not 4. And that's it. So now I'm going to skip loop A. Basically, loop A, if you think about it, if you take out the two equations from loop B and loop C, you end up with loop A. So it's the same thing. So I'm going to try to do this with the matrices. Instead of sitting here solving a system, it's going to take forever. So I have I1 plus I2 minus I3 equals 0. I'm going to organize this. I'm going to look at B here. Negative 45. I have negative 30 for I1. I have nothing for I2. And I have negative 41 I3. Then for loop C, I have negative 80 here. I have 30. This is I1. 30 for I1. I have negative 21 for I2. And I have 0 for I3. All right, let's make sure I got that right. Okay. Yep. Now, when you do this here, you're going to go to your calculator and you're going to create a matrix. It's going to be a 3 by 4 matrix. So these are the coefficients of that matrix. It's going to be 1, 1, negative 1, and 0. And here is going to be negative 30, 0, negative 41 I mean, and negative 45. Then you're going to get 30, positive 30, negative 21, 0, and negative 80. So once you create this matrix, you're going to go to, I think, second matrix. You're going to go to the mat. You're going to go to option B, and you're going to do that RREF, which stands, I think, for reduce row echelon form. And you're going to, it's going to ask you for which matrix you want to solve this. You're going to put in this matrix here. You're probably going to call it A. It will actually spit out the answers for you. So if you don't know how to do it, you can, if you haven't done it in class, just go on YouTube and find a video that shows you how to do the RREF. Okay? And that should do it.